Hello, good morning, and good afternoon, and good evening. Welcome you to the World River and Delta System Source to Sink webinar series. And today is December 23rd, and this is the number 35 of Source to Sink webinar series. And also, this is the last one in 2020. As we know, the year 2020 is a very special year. And it's a very challenging year also. For many of us, I think maybe everyone in the audience, we did not experience World War II, but we are experiencing this global pandemic. I'm not sure this is the last one. Most likely it will not be the last one, but definitely this is the first very large, extensive, and a huge impact one, at least to our life so far. But very luckily, we are able to organize this webinar series during this very difficult time. And we connected this community, the Source to Sink, the River and the Delta study group together. Every week, we are able to come together to learn each other and to discuss some very interesting topic. Today, we invite Professor Jingping Xu from Southern University of Science and Technology in China, and come here to talk about the Yellow River sediment, all the way from the Bohai to the Yellow Sea. Before I introduce Jingping, I would say a little bit about this talk series. So let's see. So we started this talk series from August, and almost now for 4 months. And so we have 35 talk already. So we all the way, we have Eduardo talk about the Amazon, the Edward Anthony talk about the mud transport along the Amazon all the way to the Orinoco. And so a couple of people like Dave DeMaster, Steve Keel also talk about sediment and carbon transport. And Sam Batley, Kevin Xu, Mead Allison, and Liz, and even the Torbjorn talk about the Mississippi River Delta. And back to the Europe, we have our colleague Ruri talk about the Nile River derived sediment, particularly the longshore and the cross-shore transport. And our colleague Serge Benet talk about the Rhine River in the Gulf of Lyon. And so then if we move to the Asia, our friend Peter Clift talk about the Indus River here in the Arabian Sea. Steve Gilbride talk about the Ganges-Brahmaputra. Our friend Robin Nichols from UK talk about also the social impact, environmental impact. And Steve Keel and myself and Yotes talk about the Uravati River, and a couple colleague Philip Mendel talk about the Mekong. And so Hojia and Professor Liu talk about the Yellow River. And so today, all those previous talks has already been archived very well online. So if coming here, so if you missed some of those talks, as you can see, all those talks from August the 5th to today now, and so this is the last one this year. And in the spring, from January 13, we will resume this talk in the spring semester. Chuck Neutral we will give a talk on Wednesday, January 13. Then we have a whole bunch of fantastic talk lined up. And all those talk, as I mentioned, is archived on our YouTube channel. As you can see, all those talks. And at the same time, thanks to Jingping Xu from Tongji University, she also put a copy on the Chinese Bilibili station. So all those talks with the caption, scripture with it, if you want to study and replay. So these are wonderful resources. So now I will talk a little bit more in the beginning of next semester. But back to today. So Jingping and graduated from Ocean University of China, back that time still called Shandong College of Oceanography, and got his PhD from that as a 2 years postdoc at Louisiana State University, then working a long time, almost 20 years in the US Geological Survey. Then 2014, 7 years ago, he back to China, Ocean University, and then as a professor, and now he is a professor in the Southern University of Science and Technology. And so his research is well known as a turbidity current, particularly working on the submarine canyon process and also observation sediment trap bottom boundary layer sediment dynamics. And he is also editor of a Science Review in the last 3 years, and also the IODP, and also adjunct professor at the Tongji and Ocean University of China. So today, I think Jingping will talk about the Yellow River. The Yellow River, he studied the Yellow River almost 40 years ago. So Jingping, now is your turn.
All right, thank you. Can you all hear me okay?
Yeah, we can hear you good. Please share your screen.
Share my screen. Okay, thank you, Paul. Thank you for the warm introduction. And I really want to acknowledge and thank Paul, who almost single-handedly organized this talk series. You have done a big service to the community. Many of us have benefited a lot. At the same time, you made me nervous tonight because the 20-some names you just mentioned, they're almost like a who is who in the geological oceanography and S2S community. So I feel honored to be the last speaker of this series. So as Paul mentioned, my talk today is about the sediment transport of the Yellow River sediment from Bohai Sea to the Yellow Sea. Before doing that, let me see if I can, okay. For those of you who know me well, for the past 20-some years, my main study was about actually submarine turbidity current. On the left-hand side of the screen is the Monterey Submarine Canyon on the west coast of California, where I have done most of my work in the past 20 years and published a few papers that I feel proud of. After returning to China in 2014, I continued this research of turbidity current in submarine canyons. On the right-hand side is where I currently have a project funded by NSFC to study the turbidity current coming off Southwest Taiwan and into the Manila Trench. You see You see my cursor as well? Okay, see the red stars, a few moorings we placed 2 years ago. So far, we have recovered some of them, and two of them are still in place. And the other symbols on the map are a few box cores and gravity cores we have collected. And we also ran some multi-beam bathymetries at the key section along the Manila Trench. As you all know, like people say, follow the money, right? As the community, as a scientist to study the source to sink of sediment, we like to say we follow the sediment. On this map to the right, let me close this, are the a collection of numbers put together by Steve Q and other people and presented at a meeting in Xiamen, China last year. I remember in September or October of 2019. What I want you to pay attention to are the red numbers and the black numbers. Those are the volume of sediment into the ocean per year. For example, in terms of the Yellow River, the red number represents the historical volume, and the black number is the present day's volume. You can see a big change. Another thing I want you to pay attention to is you add up the volume of three large rivers in China, Yellow River, Yangtze, and the Pearl River. It sums up to almost like 600 million tons per year. Well, if you look to your left into the Adam Sea and Bay of Bengal, it's almost equal the volume of Irrawaddy that I know Paul has been studying for quite a while. And more importantly, if you look further to the west, the Ganges Brahmaputra almost bring 1,060 to be exactly, million ton per year. So if you follow this sediment, so very clearly where your next stop can be. That what I want to say is I just came off a meeting 2 days ago to discuss some potential project in the Indian Ocean. One topic is to further investigation of sediment delivery system into the Bay of Bengal by the Ganges Brahmaputra River. And I almost certainly that there active submarine turbidity current going on, evidenced by the multi-beam, almost like a river type of channel at the water depth of thousands of meters. Okay, back to the topic today. First of all, I want to thank my team members. Without them, today's talk wouldn't be possible. From the top, Wu Xiao and Bian Changwei are associate professors from Ocean University of China. The rest of the handsome guys are my students, and some of them graduated 2 years ago and this year. For example, Li Bozhang is currently an engineer in Huawei, and Duan Haiqing just finished his PhD and getting a job in SOA. I don't remember the English name nowadays. And the rest of them are my current students. Thanks to all of them. one more picture. That was me, the young guy. That was me 40 years ago. And I was standing next to my PhD advisor down right. That was my second year of graduate school in China, Ocean University of China. At that time, we had a US-China collaboration to investigate the sediment transport and other things in the Yellow River Delta. I want to thank Don and my advisor too. A little bit of background. I apologize for reusing this map, but because I need the number and I like it very much, so I do it again. The map on the left is almost like a Bible to the S2S community. So I also want to say you would break the law if you do not present this map when you do a talk about S2S. So the point is, source to sink has been a focal point for the past 20-something years. As Paul mentioned at the beginning, the world communities have spent a lot of money and effort to try to figure out the delivery, the transport, and the final fate of terrestrial sediment brought in by the major rivers of the world. And this big black arrow represents Southeast China, including China and Bangladesh, India, and maybe Australia. You can tell by the size, Southeast China, Southeast Asia is a major focal point of that S2S study. I used several figures from the talk given by Professor Wang Houjie of Ocean University of China 4 or 5 weeks ago, I remember. Yellow River has its historical and cultural importance in China's civilization. We still call the mother river of the nation, and it got the historical data run back to almost 4,000 years ago. That's about the same period of time for maybe longer than Chinese civilization. But what I want you to pay attention to is starting about 2,000 years ago, because 0 here, you can see the river, Yellow River becomes muddy. The sediment concentration increased exponentially to a point. And this point, we'll come back to this later. And this surprisingly, or unsurprisingly, correlated quite well with the population explosion of China. And also in the history of the Yellow River, for various reasons, the downstream channel has shifted back and forth many times. And the year between 1128 and 1855, the Yellow River actually emptied into Yellow Sea instead of its current position, Bohai Sea, and separated by the peninsula we call Shandong Peninsula. Economically, the Yellow River is also very important because of its delta. The Yellow River has been building for the several thousand years, for several thousand years. And for example, in Bohai Sea, as you all know, there is a big oil field, Shengli Youtian. It's actually many of the infrastructures built on top of the delta. So I want to emphasize three things. The Yellow River disposal system has a tremendous sediment supply, huge sediment supply, and it's frequently shifting channels back and forth, and to build by the current account 10 or 11 delta lobes, okay, and has a strong land building capability. Some background. This is the figure from Wash and Nitrauer in their paper in 2009 paper. What I want to show you is based on their characterization where Yellow River would fit. Okay. If I click my mouse, this arrow, it goes like this. If the sediment discharge of a river is smaller than this, it goes to this direction. If it's larger than this number, 2 million tons per year, it's go to this direction. So let's go step by step. Apparently, Yellow River is much more than 2 million tons per year. So you go this way. If you go further, the shelf width is it's wider than 12 kilometers. So continue go this way. And but over here, so it goes this way. This is what Chuck and Wash called proximal accumulation dominated, the type of river delta. And that's not the end of the story. In East Asia, the East Asian monsoon play a big role in rainfalls and sediment production in the catchment river basin and sediment delivery. Of course, you have more rains, you have more water in the river. So if you follow the black arrows, it can also make, why doing that? Subaqueous delta cliniforms and the marine disposal dominates the system. So primarily it's a PAD system, but with a twist of East Asia monsoon. So the overall question is, how were the huge volume of sediment transported from the Bohai Sea to the Yellow Sea? This is an old topic. I mean, I can count with at least 10 or 12 Chinese scientists spent almost their lifetime to study this topic. Hopefully, my talk today can bring you, the audience, some new perspectives. In 2015, I was funded by NSFC to study this Yellow River project. And this is almost the last year of that project. We were trying to catalog our findings and our products. So the slide you see from now are all published or to be published. Still some background. As we know, in this system, there are two major forces. One is the wind, the East Asian monsoon. It's very clearly divided by the winter season and the summer season. In the winter, it's mainly come from the north or northwest or northeast sometimes. And in the summer, it's reversed. So that's a typical signature of the East Asian monsoon. Ignore the color. It's actually the wind curl. So I don't think I will explain what the wind current is at this talk. So driven by the wind, and if you remove the tide, previous study has come up with a long-held concept or understanding. They call it Beijing Nanchu, meaning across the strait. This is we call Bohai Strait. So on the west side is Bohai Sea, on the east side is Yellow Sea. So this is the strait. So across the strait, the Yellow River water entered the Bohai Sea from northern side of the strait, which is much deeper than the southern side. And what comes in must go out, right? So the river, the water, the Bohai Sea water goes out to the Yellow Sea from the southern side. So the red one is called the Yellow Sea Warm Current, and the blue one called the North Shandong Peninsula Coastal Current. In the summer, this is the publication by Zhou et al. In 2017. It's too complicated, but overall, if you average it, you can still see, it tend to go into it to Bohai Sea from the north and coming out from the south. So what we want to understand a little more about, how does the seasonal variation of East Asia influence East Asia monsoon, influence the long distance transport of Yellow River derived sediment. Basically, the Yellow River sediment coming out from here, how do those sediments get out? And what control the exchange flow variation, the so-called north in and south out. To be able to do that, we kind of conducted our investigation in three different time scale. One is we call the snapshot. In this effort, we basically conducted a so-called phase average detiding cruise. If you are not familiar with this this name, we all know detiding. If you have, say, you have moorings here or here or here, and you have a long time series, you can use various filters to remove the tide. But that's too costly, right? It's okay to put one or two moorings, as I showed later. We did have two stations, but if you want to get the average of the whole strait, are you going to be able to put 10 or 12 or 20 moorings? If you Bill Gates probably can, but we're not Bill Gates. So we use this method, the first proposed and presented by Professor Wu Hui of East China Normal University, who is probably in the audience. So Professor Wu Hui, correct me if I didn't do it right. The way we do is these are the preset position across the strait. So we pre-calculated the timing and the position of each site. For example, we start our boat at this point. We need to get to the next boat by a certain time, to be exact. And we do the current measurement and CDT drop and so on and so forth. And we go to the next station and next station. We do this cross-strait survey 3 times. That's what this M equals 3 is. And these are the intervals. Within 16.5 hours, we need to repeat our survey. So this way we can remove the major tide, which is M2 tide. Okay. And the next one is we call in situ observations. You see this red triangle and a black triangle. these are the two locations we deployed moorings and bottom tripod, and also had anchored boat for CTD cast and so on and so forth. We did this both in summer and in winter cruises. Because of the several restrictions, for example, money strings and other things, we were only able to do 1 or 2 weeks at a time. Okay. And that's for synoptic time scale. For seasonal, we have to rely on numerical model. So Gust is a coupled wave and current sediment transport model developed by USGS colleagues John Warner and Chris Sherwood. And in addition to that, we also ran another model to do a dye tracer simulations. And we used the sediment trans model to simulate storm event. And we also did some numerical experiment. Oh, by the way, these contours are a deposit first found by Professor Jingping Xu and others, Professor Yang. So these are the contours, and the numbers are the thickness of the deposit. Of course, we all assume these deposit, the source to this deposit are the Yellow River sediment. Sorry, I have to go back and forth. I'm not going to go into the detail of the model, and we'll simply show the simulation in the later on slide. Okay, some result from the PAM survey. On the lower left, the contour plot. So do you remember I told you that in winter and summer, we did both surveys? So you can see the temperature, salinity, and turbidity. So both the temperature and salinity clearly show, as you would expect, it's well mixed in winter. It's both the salinity. This is the southern side, the shallow, and this is the north side, the deeper. So it's well mixed across the strait. In summer, but it's much different. In summer, there's strong stratifications. The thermoclines at the 10 to 15 meters. And in terms of the turbidity, we found it's much turbid in winter than in summer. To your right are the detided, we call it residual current. The different colors represent 3, remember I told you three trips? So I forgot which is the first and which is the second. But you can, the red one, the first trip, the residual current is stronger in the southern side, but on the second one or the third one, it doesn't really matter. It's actually reversed both sides of the strait, right? That's in winter. In summer, it's essentially the same. The point is, if you cross back and forth, you, by this phase averaging method, you get a snapshot, and theoretically you can average these 3, you get an average, depth average of the cross strait flow and sediment transport. So this is the simple result. In the winter, the negative values are in the direction entering to the Bohai Sea. and the blue are the positive we call it outflow, out from Bohai Sea to the Yellow Sea. So this is the winter result. You can see it's almost after averaging, detailing the average flow, you get the inflow almost across the strait, except for the little bit in the deep channel on the northern part of the strait. So the blue square are the time period where the winter cruise were conducted. So this result is rather inconsistent with the long-held understanding of the northern in, southern out, right? So I just want to point that out to you. In the summer, one thing you notice from the this plot is you actually get a baroclinic pattern, namely the top layer on the southern strait, the top layer go into the Bohai Sea. No, the bottom layer go into the Bohai Sea, and top layer come out from the Bohai Sea. So this is very different from what we saw in the winter. We call this baroclinic. I don't know how precise technically, but this is what we call. Another thing you pay attention to is the size of the arrow. In the summer, the arrow is much smaller. The residual current is smaller, and also the direction of the arrow pointing. Remember, in the winter, the arrow goes in. Now, in the summer, it's actually pointing to the Yellow Sea. I think I need to speed up a little bit. So these are the results for our mooring station. This is the sketch of this is the bottom of the strait, the southern part, the northern part. On the southern part, we call station T1. We only have one boat. We lower the ADCP and lower the CTD cast. On the northern part, we were able to put a bottom-mounted platform with the ADCP looking upward, and also a subsurface mooring. So these data are much more complete. So we jump in the summer. The U component. So we caught a wind gust in the summer. You know, people understand the wind is much stronger in the winter than in summer. But in summer, sometimes there is a pulses of strong wind. So this is one of them. We happen to be able to collect the data. And during this wind gust at the deeper station, we can see the inflow when the wind just picks up. This is the sea level, and it's corroborated with the sea level pretty well. So the sea level continues to rise as the wind gets stronger, and the drop as the wind weakens. This is another winter storm. So this period we observed, we were able to get the data, and there are no surprises because it's well mixed in the winter. The color of the magnitude and the arrows are the direction. There are no surprises here. But in terms of this, the sediment transport, the sediment concentration, these are the numbers calculated from the backscatter, ADCP backscatter. Before doing that, we run a calibration with known sediment concentration. You can see the regression line is pretty well. So we trust this is reliable. So at the shallow side, it's T01. During the storm, you have almost very high concentration across the water column at 20 meters or so. But in the deeper side, the water depth there is 50 meters. You see nothing. So the deep channel to the north side are not sensitive to the storm resuspension. And in terms of the transport, if we separate the building up and the relaxation part of the winter storm, actually both the transport of water and sediment reversed during the 3 different phases of the winter storm. And we also ran the model. This slide basically showing you the validation of the model. We used the 2 different parameters to validate the model. The blue here are ADCP measured velocity, wave height, and the SWAN model. You can see either the wave height, the water level, the velocity. They matched. I have to say it's fairly well. So the model result, we think they're fairly good. Drink some water. Continue the winter storm synoptic event. I basically want to show you here. We ran the model for 6 days, from January 8, 9, 10. We call 8, 9, 10 are the building up phase of the storm. And 11, 12, and 13 are the relaxation of the storm. You can see the transport pattern are very, very different. And this is getting more complicated. My student, Wang Chenghou, ran the model to use the model result to explain the in and out of the Yellow River warm current and out of the coastal current. Because the time constraint, I'm gonna skip that. This is too physical oceanography to me, anyway. This is a simulation of the model, basically showing you the warm currents go in, and we call it the Kelvin wave coming out. And this is the simulation for the building up phase and relaxation phase. In terms of this is the suspended sediment flux response to the storm wind. You can see the building up phase and the relaxation phase. First, the shear stress, wave current shear stress getting stronger, and the sediment flux. Sediment, we all know this, of course, the color bar is the sediment concentration. The arrows are the scales of current. You can simply multiply the color, multiply the concentration with the current, you get the sediment flux. Let me jump to the final, not the final result, the concept. Okay, when the northerly wind built up, this is the sea level. The southern side and the northern side is tilted. So this is pressure gradient force. You generate the current coming out. And later on, when the shelf wave propagated from the Yellow Sea along the deeper channel, so it generates the inflow to the north and outflow from the south. And at the relaxation, the Kelvin wave coming out from the Bohai Sea tilted the sea level across the street this way, so to generate the inflow at both sides. This is a dye tracer. It looks interesting, but very rudimentary, so it doesn't give you any quantitative result. But I just feel it's kind of cool. Basically, we fill the Bohai Sea with dyes, run the model for a couple of days and see how the Yellow River water, Yellow Sea water go in and the Bohai Sea water come out. So take-home message is this. The sediment flux through the Bohai Strait were primarily baroclinic in summer, but barotropic in winter. And wind can generate low-frequency oscillation of barotropic flows accompanied by sea surface height fluctuation in Bohai Strait. And the cyclonic propagation of coastal trapped waves can influence the exchange flow pattern in the Bohai Strait, and stronger coastal current, intensified wave motion, and high submitted sediment concentration indicate that the throat strait sediment flux during outflow is greater than during inflow. I mean, this is almost a moot point, right? In order to make the Yellow River sediment coming out of Bohai Sea, of course, you have to have more sediment coming out than go in, right? So there are some ongoing studies need to be wrapped up for this project. One of them is my other student, Chifu Kang, is doing. Eventually, the deposit. Eventually, we want to be able to figure out the deposition rate. There is still a kind of puzzle here because when we collect physical oceanography data, the current, the flow here is much stronger. So when you have strong flows, the sediment tend to be eroded away, but you know, it's right on the top of the historical deposit. So this is something we have to work hard on and try to figure out. And we also work on some internal tide. We realized there are actually critical slope that should be able to locally generate internal tide that affect the bottom shear stress. And with that, these are the spot I have from where I have collaborated with the scientists all over the world. And I hope in the future we do more work together. At the same time, I want to thank you very much, and Merry Christmas, Happy New Year. And that's the end of my talk. I'd be happy to entertain any questions.
Oh, thank you, Jingping. I think that's very interesting, very, very great talk. And because the Yellow River Jura sediment, as you mentioned, you know, some our advisor, teacher, the last generation, they working since 1960s. They understand basically some, you know, sediment mainly coming out of the Bohai during the winter session, but they don't know exactly how much. And later on, there are some more studies in 1990s and 2000, 20 years ago. And so now, we have much better understanding the dynamic portion. So it's very interesting, but it's still a mystery, but now we get it better and better. So for the audience, if you have any question, you can go ahead, unmute yourself and or raise your hand virtually, or just go ahead to ask Jingping. And for the student, if you don't comfortable asking English, Chinese is also okay, but anyway, just ask a question, okay. Okay, so
should I stop sharing my screen?
Either way, you can leave it on here. And Jingping, in your talk, you didn't really give out any specific quantitative number. How much exactly the material come out of Bohai every year, particularly different season, like during the winter or during the summer? So what's the number? I know a couple of colleagues, they already give some kind of estimate. What's your number here?
Okay, let me share my screen again. Yeah. Okay, actually we did have some precise numbers. For example, for this winter storm, at the synoptic time scale for this winter storm, at this first phase, the WF here is water flux, and SSF is suspended sediment flux. We have pretty solid numbers here. What I want to show you here is you see the first phase, the second phase, and also you pay attention to the difference between the two stations, the northern station and the southern station. It's almost 1 order of magnitude difference. So of course, by from the measurement, this is what we measured. Chen Hao's dissertation is going to be about how to use those measured numbers to validate his model, so we can expand from this synoptic event to seasonal, and hopefully to get annual time scale and even longer time scale transport.
Okay.
We want to do it right.
Cool. That's good. That's good. Anybody else from the audience? Anybody have a question?
I have one.
Yeah.
Thank you for your great presentation, Professor Xu. My name is Yan Li. I'm a doctoral candidate of Professor Xu Gao, and I have a quick question about the sediment transport during storm events. So it's quite straight. Just did you observe any significant green size change? About the sediment flux during storm events?
You mean green size change in the water column or on the bed? Yeah, you mean in the water column, suspended sediment, right?
Yes.
In this particular study, we haven't spent a lot of time to work on grain size. We did have some samples. That's how we were able to calibrate this ADCP numbers. But I need to recollect my my thought. I don't remember we see much difference between the north and the south side. On the bed, yes. On the bed, yes. There's a big difference. But just from top of my head, when you have a storm, okay, during the storm, the southern part of the strait tend to be resuspended a lot. And the bed sediment in the shallow southern part are much finer than the bed sediment in the deeper channels, basically because the tidal current in the deep channel is much stronger. So the finer materials are prevented from settling there. So these are the basic background knowledge we all have. But in terms of the time variation of the suspended sediment grain size, I assume they change, but I don't have the data.
Okay, thank you.
Any other question? That's very, very interesting. Jingping, other question. This is a old question, also a challenge question. Based on Chen Hao's model, you see he showed there's some warming water flowing north and the Shandong coastal water flow out to the south. So is any flux or any sediment come from Yangtze all the way travel through the Yellow Sea, reach to the north part, North Yellow Sea? Do you think it's possible?
Probably possible. I mean, I believe the coming Tuesday, Professor Wu Hui is going to present the talk, our MSF seminar series. I believe he's going to talk about the Yangtze diluted river water distribution. I think, you know, of course, this simulation, this animation doesn't have the southern boundary south enough. But if his diluted water can go to the Subic, for example, it can get back into the Yellow River warming water and eventually get some particles into the Bohai Sea.
Okay, that's very, very interesting. You know, in the eastern tip, the Shandong Peninsula, the tip, the eastern side, it is very true. Near shore from the Shidao, eastern word of Shidao, the bottom current very, very strong. Actually, the sediment is there's no more than a fine mud. Instead, there's some even bigger rock or pebble even sitting on the seafloor there. So, you know, definitely then we need more survey, even study to understand why the sediment bypass, how they continue to travel to the south, even a little bit east. So
yeah, this is similar to what I just asked myself a moment ago. You know, here at the tip of the peninsula, nowadays the current is so strong. Why is there a thick deposit there? So I remember you proposed some years ago, I think some years ago. This is the Yellow River Delta.
No, they call distal depot center.
Oh, well,
Subarqueous Delta,
yeah, you know, the some stage of low sea level, right?
Yeah, but I don't know now. You know, we always change our mind as a scientist. But it's very good. But the strong shear stress, they cannot keep sediment there. But very immediately out of the boundary, there's still a higher sediment accumulation. So, but anyway, let's see if any other question from the audience. Yeah, if any question, go ahead.
Hi, Paul. This is Hui. Can you hear me?
Yeah, go ahead.
Yeah, I just have a web connection problem, and when I reconnect the internet, I heard my name mentioned by you. So I think I should say something. Okay. You're talking about the deposition around the head of the peninsula. I am also thinking about this question. Maybe we can look at the so-called buoyant coast current. That means in this area, because there are multiple freshwater rivers into the Bohai Sea, so it can form some sort of strong buoyant coast current, which carries sediments to a far distance, just like the Zheming mud belt area. So nowadays, the current is not that strong because the Yellow River has very low discharge. But what about in the history? So when there was a huge river discharge, then I believe it can form a very strong buoyant coast current which carries sediments over there. And this is one thing. That another thing that here we have a strong front over there, formed either by the river plume from the Yellow River or by the tidal front. And then the front has a capacity of trapping sediments, as we know that. So it might be another reason that sediment can be deposited over there.
Yeah.
That's my opinion.
Yeah, there are, in the recent years, there are a couple of papers. Actually, one was by Hou Jie's group, and the other one by Xu student. Right? I think that they all talked about, they call it shear front.
Yes,
And
indeed.
shear front, somehow, well, I understand shear front prevented the suspended sediments from going further to the east.
Exactly, yes.
But this still doesn't answer the question. Any measurement, either the mooring measurement or the tripod measurement, the speed,
the current too strong.
The deposit, are too strong.
Yeah, Jingping, if you move down a couple slide, one more slide, move down, show the ISO patch, the mud patch, that map. Do you remember that? Yeah, this one. Of course, this is you cannot zoom in. If you see, near shore, there's no sediment near shore.
Okay.
There's no sediment here. At that point, this is a very, very, very strong, high stress, shear stress. The bottom there's no more sediment, but a little bit away from that, you can see that mud lobe accumulation.
I remember Hou Jie and Xiaobi tried to put a tripod on top of this deposit some years ago, and got lost. Just the flow is very strong.
Yeah, that's the other thing. Is still. I mean, we thought we get the answer, but actually we open other black box. That's kind of the situation.
That's true.
Same as the Yangtze, the Zhejiang Fujian coastal mud belt. We thought we understand it, but actually we really ignore it.
Yep. Dynamically, Professor Wu Hui, if you have much stronger freshwater coming out of Yellow River, and say you have a coastal current, freshwater dominated coastal current, would you somehow reduce the shear stress here, and so that the sediment would settle?
Yeah, as far as I know that if you have a freshwater front, then you like to have a very small velocity near the bottom. This effect called buoyancy arrest. Okay, you have high speed at the surface, which decrease downward, and when around the bottom, the speed is pretty small. So then, if you have a lot of fresh water, just like a Zhemin coast ocean, then, and this is a kind of front trapping mechanism that you have weak velocity near the bottom if you have a front, and you actually also have a convergence
Mm.
in the bottom, which can trap the sediments at the foot of the front. So I guess if you look at the sediment deposition over in this area, nowadays we only have very low discharge, but in the history, I guess the discharge was much higher. Then that time maybe this mechanism will be more or more significant.
Can that be modeled?
Yeah, if you have a lot of fresh water, then you like have a front trapping mechanism which can make the sediments accumulate near the front bottom. That's my speculation.
Okay, so by the way, maybe we can find other opportunities specifically discuss
Yeah.
this. And it is very interesting. You know, we can have a couple. Let's stop here. If there is no any other question, and I think Yan asked about the storm event in the distal depot center. It's not very clear. There's a couple. Recently, Professor Litia gone from First Institute. They just get a 3 deep core through their smart distal depot center, and maybe there's some new result come out, but I haven't seen the result yet. And so that's interesting. So maybe we can, at one time, we can have maybe 1 hour, 2 hour discussion about the Chinese marginal sea, the margin deposits. And then we can combine the dynamic numerical modeling and observation, you know, just to have free discussion. But anyway, we have to stop here. And thank you, everybody. I know in many, in China already 11 p.m. So thank you for your participate. And thank you, Jingping, for giving this last wonderful talk. And so again, Merry Christmas and Happy New Year. After the New Year, so we will have continue this talk series. And so I think we'll stimulate many new ideas and many collaboration. So 谢谢. Okay.